Good morning, everyone. It is so nice to have you back for another amazing Exploring by the Seat of Your Pants broadcast. And for those of you joining for the first time, first of all, meet Sadie, my needy dog, who's joining for the first few weeks of this new school year. My name is Jesse, and what we do at Exploring by the Seat of Your Pants is connect scientists, explorers, and conservationists around the world with classrooms like you through like 40 live free broadcasts every single month. Now, everything we do goes to our YouTube channel, so if you want to check out like 4,000 programs or all our upcoming stuff, it's all right there to share with your family and friends. There is so much to explore and discover. Now, before I dive in with our special topic today, I do want to note we have a Kahoot. So between our talk and our Q&A, if you want to play along with a little 4-question quiz, you can head to that game pin below. And in about 25 minutes, we're going to get to that and have some extra fun. But of all days, you are catching us right smack dab in the middle of our epic, amazing Ambassadors of Conservation series in conjunction with the amazing folks at If Then. So If Then is the greatest campaign of all time, showcasing and celebrating the most amazing women in science and exploration on planet Earth. We've partnered with them a bunch of times before, and in the lead up to the World Conservation Congress coming this October to Abu Dhabi, we wanted to feature some of the best conservation all-stars in the If Then lineup. So we've been featuring all sorts of stories on snakes and parks and bats and more. It's all on our YouTube channel. But today, we are going with something a little bit different and a little bit special. Dr. Tammy Goulet is joining us again to talk about clownfish and corals. Her work at the University of Mississippi is all around the amazing things that we call coral reefs. And so we're going to learn a little bit about from her. We're going to ask some questions of you. We're going to have a great time. And so without further ado, none of you are here to hear me talk. I'm going to turn you over to Dr. Tammy. Thank you so much for joining us again with your stellar background and shirt. And nice to have you back on the show.
Thank you very much for having me.
It is so nice to have you back. You're one of the 10 amazing speakers we've had in this series. You are one of 9 that are coming back. You just couldn't say no. And we appreciate that immensely because we get to introduce your work to a whole new group of students this year. It's very exciting.
Thank you. And I love questions. So if people even have after the presentation and afterwards, if you think about it in a few days, don't hesitate to email and contact me.
You have our email address. We'll pass them along to Dr. Tammy, and we'd love to take as many coral things as you could possibly want to know. But for now, I know you've got a big presentation to share with us. If you want to bring that up and dive in, we will be good to go.
Here we go. Okay, can you see that?
You're golden. Let's do it.
Awesome. So, hi, everyone. My name is Dr. Tammy Goulet, and I'm in the Department of Biology at the University of Mississippi. As an If Then ambassador, we had statues made of us, and that's what I'm standing by. If anyone has any questions about that, I can answer that later. So, as I said, I'm at the University of Mississippi. So let me ask you guys, are there natural, live, tropical coral reefs in Mississippi?
Ooh, what do we think? I have an instinctual answer for this, but if you want to chime in on YouTube or live with us on StreamYard, we'd love to hear from you. We've got a few tentative no's. We've got a yes, maybe because we're doing a coral program. We've got a good mix. So what do we think? Let's see. We've got our class says yes for Miss Steinhoff's class live on StreamYard. Tell us more.
So we actually don't have coral reefs. And if you are in the US, and I know that people are also signing in not from the US, if you're a coral reef biologist, you actually have to travel to see a coral reef. So it doesn't matter if I work in Idaho or in Utah or in California. For a tropical coral reef, we need to travel. And even people that live in Florida need to go to the Florida Keys. So let me tell you a little bit about where I am. The University of Mississippi is in Oxford, Mississippi, not in England. To put things in context, William Faulkner, the Nobel laureate house is in Mississippi, and he used to live here in Oxford, Mississippi. And if you've heard of Elvis Presley, he was born in Tupelo, Mississippi. And one other fact that I'd like to share with you guys is that I have 5 children. And the reason that I bring that up is that sometimes people think that if you are an academic or if you have a job that demands traveling, you can't have kids. And I want to tell you, you can have kids if you want to have kids. So where do I go for my work? I go all over. So, for example, I've worked in the San Blas Islands in Panama with the Kuna Indians, and you can see some of the Indians paddling in a canoe here. I have worked in the Florida Keys, and this is a picture from the Florida Keys, and you see the fish, which naturally draws your attention, but all the various things around the fish are octocorals, and we're going to talk about corals in a minute. I've worked in Puerto Morelos in Mexico. I have gone to the Galapagos Islands. I've also gone to a little island in the Caribbean called Ceiba. And in Ceiba, in the port, there is a mural. And if you focus in on the mural, you see that it says symbiosis. Nothing in this universe exists alone. And I work on symbiosis. And so I will then ask you guys, do you share a room or a house with someone else, whether they're a relative or not? If you do, why do you do that? What are the benefits? And what are the disadvantages? What do you guys think?
Ooh, let's see. So I'll start with myself. I share a house with my wife. The benefits are it rocks because like my best friend gets to live with me. The disadvantages, I don't know. I don't get to play as many video games as I used to. I used to be really good at video games, and now I've had to cut down on that a little bit, which is kind of sad sometimes, but mostly good. 99% good. We've got a lot of students that have brothers or sisters, certainly with their family. Everybody shares with their parents at this age, which is great. Let's see. Benefits, get your food. Good to have groceries. Disadvantages, sharing things. Yeah. So the standard answers, which I think we're going to have some maybe choral relatives to this idea.
Mm-hmm.
Sweet. Perfect, Tim.
Wonderful. So you guys, what you described is basically symbiosis, but there is a big difference. And the difference is symbiosis, the definition of it is living together of at least two organisms from two different species. And that definition was set in 1879 by Anton de Bary. And so even though you may think that your brother or sister may be an alien, they're actually humans, right? But all the things that you mentioned are relevant for symbiosis because organisms come together and form a symbiosis because there are benefits and there are sometimes disadvantages. It's not always perfect. So let's look kind of at the definitions of symbiosis. We have kind of a spectrum. You may have heard of parasites, and you may have heard of the word mutualism. So parasitism is usually what happens when one of the partners benefits while the other is harmed. And mutualism is when both partners benefit. But you have to keep in mind that the benefit is context dependent. So right now it is beneficial, but that doesn't mean that it will always be. So you have that kind of definition. And within that, you have definitions of an ectosymbiont is a symbiont that is on the outside of the host. So that's usually the larger of the two. And an endosymbiont is a symbiont that is in the host. Then you also have facultative, which means it can either have the symbiont or not. So the example here is the moray eel with the cleaner shrimp. The moray eel can or doesn't have to have the symbiont. And then you also have obligate symbiosis, where the organisms, the two individuals cannot coexist, or at least one of them cannot coexist without the other. So those are kind of definitions, and I'll put that in context of corals. So then you have hard corals, which is one of the things that I work on. And hard corals are basically a creature living in a cup, and that cup is made of calcium. And so if you think about it, this is an example where you have a plastic cup, and this is a glove, and basically you have the animal living inside this cup. So the skeleton is on the outside, and these are the tentacles and the polyp. The polyp is the organism that you see here. And so these guys have two types of skeletons. They actually have an external skeleton, which is the calcium carbonate, and they also have an internal skeleton, which is hydrostatic, hydro meaning water. And what do I mean by that is that their tentacles, so it's the little arms that you see, fill up with water. And so when you fill up with water, they expand. And when you let some of the water go, they become limp, right? And so this is a way for the tentacles to come out or to relax. And so you have two different types of skeletons. The other thing is you have sea anemones, and you may have watched Finding Nemo. And sea anemones are basically a coral, one unit of a coral polyp that doesn't have the skeleton around it, but it still has the hydrostatic skeleton that makes the tentacles firm or very loose. So let's talk about corals and anemones and put them in context of where they belong. In the animal kingdom, you have this phylum that's called Cnidaria. And in the Cnidaria, you have these 4 classes. Hydrozoa, you may have heard of Hydra. Scyphozoa, jellyfish, you may have actually encountered jellyfish. And then there's this Cubozoa. And then there's the Anthozoa. In the Anthozoa, you have the corals, the octocoralia and the hexacoralia. In the hexacoralia, you have the hard corals, and you also have giant sea anemones. And in the octocoralia, you have the octocorals. In the Caribbean, we have Gorgonian octocorals. So this is kind of a background of cnidarians. And what I investigate is I investigate symbiosis between cnidarians and other organisms. So hard corals, many octocorals, sea anemones have a mutualistic relationship. So it's mutually beneficial between dinoflagellate algae. So these are single-celled algae, and they are in a particular family. Now, the algae are found within the host, within the tissue. So that is known as an endosymbiont, right? Because they're within the host. And there is benefits here to both of them. The algae do photosynthesis, like other, photosynthetic plants, various things like that. And so they transfer the sugars from the photosynthesis to the host. The host gives the algae protection because the algae are within the host, so they're not outside, open to, exposed to predators. And also the host, being an animal, releases nitrogen as their metabolic waste. I mean, we go to the bathroom as well. And in coral reefs, nitrogen is not abundant. And so the algae need the nitrogen in order to make amino acids and to grow and to reproduce. So it's mutually beneficial. So this is a picture of one of these of a coral and and 2 polyps, and you can see that the algae are in them. So the coral animal itself is actually see-through, and the color of the coral is from these algae that are within it. Now, when the algae leave the coral, so there's a loss of algae, or they are potentially stressed, so they don't have their photosynthetic pigments. What happens is you see through the coral, which is a clear animal, to the hard skeleton. So it looks like the coral is bleached. And so that's the name coral bleaching. And you may have heard of the term coral bleaching because it's sometimes referred to in the news. And coral bleaching is usually a sign of stress. So how does coral bleaching come about? Well, we have a changing environment right now, and there are certain things that happen in the environment. So, for example, we have seawater temperatures are going up. You may have heard of that. The seawater is getting warmer. Sometimes it gets colder. For the most part, it is getting warmer. There is increase of ultraviolet radiation that penetrate through the atmosphere and reaches all of us, including the oceans. There is this thing called ocean acidification, which affects corals as well. And there's this big word called eutrophication. And what that means is if you've ever seen a coral reef or a picture of a coral reef, it's in this bright blue water. And that's because there are not a lot of nutrients in it. And this monster of a word means that there's more nutrients in the water. And as a result of that, you often have algae growing in it. So if you've been in a lake, lakes usually appear green in color because there's a lot of algae in them. Coral reefs live in pristine blue waters, or they used to. And sometimes with human waste being spilled into the water, you have algae that grow in the water, so the waters look green. The other thing is this. Have you guys ever seen one of these bags where it says, this bag is not a toy, to avoid dangerous suffocation, keep away from babies and children? Have you guys seen something like that?
I've seen many of those in my time, and I'm sure some of our students have too. Yep.
So you have so we have a lot of plastics, right? And those plastics end up all sorts of places. like on coral reefs. And the warning on bags for humans is, of course, if you put a bag over your head, that is dangerous because you may suffocate. Well, if we put a bag, not us putting it, if it with the current ends up on a coral, or in this case on a sea anemone, then that can suffocate the animal as well. Not only the coral, which is an animal, but the organisms that live around it, like these sea anemones, like these anemone fish. So you have this mutualism between a sea anemone here, anemone fish, and actually it's a three-way mutualism, because within the sea anemone, you also have the dinoflagellate algae. So look around, you guys, in your classes. How many plastic items do you see? And what do you think happens to those items, for example, when you no longer need them, or if they break, for example? What do you think?
I love this question because what it underscores is that way more things are plastic than you ever think they are. I have like a figurine on my desk that's plastic. I have a clock that's plastic. A bit of the computer that I'm looking at is plastic. The keyboard is plastic. I've got plastic on my pen that I've got in front of me. There's plastics in my phone. There's plastics on my mouse pad. It's everywhere. So if you're in your class, like look around, see what there is, because there's more than you would ever think possible. My glass is plastic. My couch is a type of plastic. I mean, it sounds so silly, but you don't think of things in your couches as plastic. They look like fabric, but it is a type of plastic. Quite a bit of modern furniture is that like that. So it's everywhere. I'm basically in a giant cocoon of plastic, and I didn't even know it. And I love this message. Cool.
So plastic is all over, right? And some of you, I know in Canada, it's a big deal to recycle, and you have different bins and you put out, and so in the US and in other countries. But even when we do recycle, and even when many people throw out plastic in trash, sometimes it ends up in the sea, like in this case. If you go to the beach and you have a plastic bag, and then with the wind, all of a sudden it's in the water. Now, not only that, but the plastic doesn't stay complete, right? It eventually breaks down. And when it breaks down to little tiny pieces. Those pieces are plastic. Scientists refer to them as microplastics. So plastics are dangerous as well in this changing climate, because not only do they suffocate whole organisms, and not only that, you may have heard of sea turtles. Sea turtles eat plastic because sea turtles eat jellyfish, which are also cnidarians. And so they think that a plastic bag looks like a jellyfish, and they consume it, and then they have it in their stomachs, and it gets all messed up in their body, right? So you have these things, plastics, and then when plastics break down, you have microplastics. Well, microplastics are eaten up as well. So this is a picture of a polyp that I showed you before. This is from the side. If you look at it from the top, this is a picture of polyps, and you see the blue dots. The blue dots are little plastic pieces that the investigators fed to the corals, and they put it in the water. And what happened was the corals took up the plastic. So corals, these tiny organisms, also eat plastic, and that damages them as well. So it's not just the big plastic suffocating them, it's also these small broken down pieces that can hurt them as well. So I'm going to tell you about one study that I did. Do you guys see that triangle in front of you?
Yeah.
Can you tell me what it shows?
Yeah, we've got a camel crossing, unexpected, not your usual place. I don't have any of those in Newfoundland where I live.
So yeah, well, I've seen moose crossings in Canada, right? And there's deer crossings. So this is a camel crossing. And in case you were wondering, it says, beware of camels near the road. And I took this picture on the way to a coral reef. We don't usually think of coral reefs in deserts, but they also occur in deserts. And so this study was done in the Red Sea, in the Gulf of Aqaba or Eilat. Those are two names for it. So that's in the blue circle up here. And if you look at that blue circle, this is the desert on the one hand, and on the other hand, there is a flourishing coral reef. And this is the coral reef that is there. And in this study that I will tell you very briefly about, we looked at sea anemones and anemone fish. And in order to do that, I can't breathe air underwater with without equipment. And the equipment is scuba diving, right? So I'm a scuba diver. Scuba stands for self-contained underwater breathing apparatus. Most people just know it as scuba. And so because I cannot breathe underwater, I don't have gills like fish do, I need to get my air from the not from the surface, but I carry it on with me. So I have a tank on the back that you can't see right here, and I have a breathing apparatus that I put inside my mouth, and that's how I can work underwater. So the animal that we studied is the two-banded clownfish, and it lives in two different sea anemones. This one is the bubble tip anemone. And for the clownfish, this is an obligate symbiosis, which means you are not going to find clownfish without their sea anemone. And for the anemone, it is facultative, which means that some anemones have clownfish and some anemones don't. So they don't have to have the anemone to survive. And then if you remember, I told you that even within the anemone, you have the algae. So this is actually a three-way symbiosis, and it's all mutualistic. And this is the other species of sea anemone that they live in. This is the tentacles here are much thinner. And so usually smaller anemone fish live in these anemones. And so here you see, I told you guys that I breathe underwater, and here you see the tank that I need to carry on my back because otherwise I don't have air. And so what we did is we went into the reef and we looked at along a certain area of the reef, looked at every single sea anemone, and we created a map. And in that map, we noted if the sea anemone had anemone fish, whether they were big, they were small, whether they were tiny new recruits because they're little babies, whether they were juveniles, or whether they were adults. And the adults, you have adults, and then you have what's known as breeding pairs. So these particular fish, anemone fish, live, when they breed, they live in a pair, a father, a male and a female pair. And so they usually live in their own anemone. And so what you see here is the number of anemones, sea anemones in 1997. I'm sure all of you were alive then, right? In 2009 and in 2015. And these are the two species, right? So the bubble tip anemone are the thicker ones, and the long tentacle anemone. And what you see is from 1997 to 2009, there was a drop in the number of anemones. And that drop is pretty significant. There are only 25% or a quarter left. And from 2009 to 2015, there was further a reduction. So you had only 27 anemones in total left in that entire reef area. Now, if you look at the anemone fish, you also see that there was a drop. So you have here the babies. Those are the ones that are new recruits, that they join an anemone from the water column. You have teens, so these are the ones in blue. Then you have the adults, and the adults are separated out. They're all in red, but either the stripes are adults, and then the red are breeding pairs. And you can see that throughout the years, there was also a drop in the anemone fish. Now, the interesting thing is that the breeding pairs, the number of breeding pairs, so that's the dark red, stayed relatively the same. And so what that created was, if you have the adult breeding pairs in an anemone and you have babies coming into this population, to this group, the breeding pairs are not going to allow other anemones to join their anemone. So they're keeping them away. So there is less and less anemones, there are less and less fish, but also all the anemones that are left have sea anemones in them. So this is like the game of musical chairs. Have you guys ever played that?
It's my favorite game. And I just have one chair here, so it's very, yeah.
So in musical chairs, if you may have done it in a party, you have a number of chairs, and then you have the number of chairs is one less than the number of players. So in this particular example, you have 4 anemones and you have 5 fish. And then the music starts and everybody walks around the chairs and walks around the chairs. And then when the music stops, the people are supposed to sit in a chair. And then one person doesn't have a chair and they're out of the game. And then you take one chair out. So now you have 4 players and 3 chairs, and you keep going until you have a winner. Well, when you have less and less sea anemones, you have less and less places for anemone fish to come into and join the community. So if the sea anemone numbers continue to drop, there will be less and less homes for the anemone fish. And that puts the whole symbiosis in danger of potentially dying out. So I'd like to end with one thing. Do you guys recognize who these two are?
It's Marlin and Nemo, my two favorite clownfish of all time.
So if you've ever seen Finding Nemo, there's a story about Marlin and Nemo. And in the first 5 minutes of the movie, Nemo's mom is eaten by a barracuda, and the rest of the eggs are eaten also. And there's only one egg left. That egg then hatches, and it's Nemo. And then you have Marlin, the dad, and they go on an adventure. So first of all, anemone fish are obligatory, so they have to stay in their anemone. So the fact that they left the anemone is a bit of artistic, license. The other part is anemone fish are sex changers. So they're all born as male, and then the largest one becomes female. So in this particular case, where Nemo's mom was eaten, Marlin should have been Marlena, because he would have changed sex into a female. But it's still a nice story between a father and a son, although it could have been a story between a mother and a son. And the last thing that I wanted to show you, the research that I told you about and the graphs that I showed you are from an article that came out in Frontiers for Young Minds, and you can find it there. And it's also been translated to Spanish, so it's completely in Spanish as well. So I'm going to stop sharing my screen now and see what you guys questions.
Fantastic. Well, thank you so much, Tammy. And I've just put that Frontiers article in the chat on StreamYard and on YouTube for anyone who might be keen. Before we dive in with your questions, we are going to do a Kahoot together. So find out who is paying attention, have some fun, test some understanding on coral reefs. So if you want to pull that up below, for those who are new to Kahoot, the faster you answer, the more points you get. And what you win is Tammy and I's everlasting respect, which is worth quite a bit. So we're going to dive in with this in just a second. If you want to help us out with any clues along the way, you are welcome to chime in, but let's get to it and get underway. Here we go, folks. All right. Drum roll, please. 3, 2, 1. And our first question is, coral is a what? What are our options? An animal, a plant, a rock, or an alien? What did we learn near the beginning? I love the cup metaphor. It's still one of my favorite things that you do. So thank you for that. But it kind of looks like a plant. I think a lot of people think it's a plant. It makes a skeleton made of rock. It's definitely not an alien. We know that much. It's from Earth. What do we think? One more second. Ooh, see, so many of you thought it was a plant. Yes, I love when we stun people. It is an animal. It's related to jellyfish. Same group as jellyfish. It's just one that anchors itself to a rock and grows from there. So this is a big misconception.
I think people think about that because they have plants within them, right? Yeah. But they're an animal.
Absolutely. I think that might come up in one of our future questions. Let's see. True or false? Coral animals have algae growing inside them that help them photosynthesize and give them their color. Let's see. Sort of gave it away. Who's quick on the draw? Faster you answer, the more points you get. So this is a big thing. We talk about this in every coral broadcast, and I think it's a really important thing for our classrooms to know. The answer is an enthusiastic true or yes. That thing is called zooxanthellae. It's a big word. I'm going to pull it up in the chat. There we go. Cool. Zooxanthellae, little guys that live inside your tissues. Imagine if you had like tree bits growing inside you, and that allowed you to take in energy from the sun. That's sort of what corals do, and it's very, very cool. All right. Terrific Wombat has our lead over Winged Panda. Question 3. How old do you have to be to start scuba diving like Dr. Goulet? So you highlighted a few amazing dives around the world. I have a scuba license as well. It opens up 71% of this planet. When did you start scuba diving? I'm curious. How old?
I started when I was 18.
Okay. So it's not 25 or 20 then. If you can start below 18. I started at 22. The answer is the fewest one got this right. At 8 years old, you can start on the path to scuba diving. You can do something called Bubble Maker. It lets you breathe underwater with a scuba apparatus. And at 10 years old, which most of you are today, you can get a scuba license like I have, which is really, really cool. And that's true even if you're in Saskatchewan or Iowa in the middle of a continent. There are lakes and quarries, lots of opportunities to dive. Very, very cool. All right. What can we do to help coral reefs? Our final question. Choose sustainable seafood. Work to reduce our carbon footprint. Dispose of garbage properly so we don't get the plastic on the reef. Or, hint, hint, nudge, nudge, my favorite answer in Q&A is all of the above. What do we think? And there we go. 5 more seconds. And then Tom Thompson, we're coming to you guys for our first question on an audio spot. Ms. Steinhoff, you'll be next. All of the above is our correct answer. Way to go, everybody. All right. Let's see what that does to our podium. Third place is Winged Panda. Incidentally, a camel for some reason. Second is Lively Tapir. Everyone should look up a tapir. They're the best animals ever. And number 1 for all the marbles. Terrific wombat wins. If you are any of these folks, let us know who you are in the chat, and way to go. We're going to dive in with our Tom Thompson crew. So I know you should be audible. Come on in if you've got a question for us. Hey guys.
Tammy, come. Hi there.
Hi.
So I've got a student approaching now.
Perfect.
Question.
For the
dog's name? Nope,
No.
not that.
for the coral reefs, in a symbiotic pair, can there be can a plastic also be a part of a symbiotic relationship?
Ooh,
Like,
interesting.
Here.
Yeah, interesting question.
Okay. So symbiosis is, mutualistic symbiosis is a between two organisms, right? Or at least two or more organisms. Plastic is not alive, right? So it doesn't fall under the definitions of what a symbiosis is. It can harm organisms, but it doesn't do that through a symbiotic relationship.
What a cool question, though. I really like where your head's at with that. Very cool, 5 6s. Miss Steinhoff's class, there's so many of you. Come on in and take us away. Hey.
Your turn.
What is the lifespan of a clownfish?
Ooh.
Excellent question. So there have been studies that show that clownfish can even live up to 30 years. And so that's why it's so sad when their sea anemones, right, are the numbers are going down because you have a very long-lived fish that is losing their homes.
Yep. What a neat question. And I'm so interested that you knew that offhand. So many species we don't know the ages of. We've actually had this question a lot in this series, and it's quite often very difficult to get the age of a species in the wild. So
well, and I can also tell you in the reef where we went to time and time again, I saw the same breeding pair. I saw the same couple.
How cool is that? Oh, they come to the same spot all the time. Like they literally live on the same anemone for their whole lives.
Yeah.
Fascinating. Very, very cool. See, a sub question we didn't even know we were going to ask. We're going to come back to our live classes for another round of questions in a minute. If you're on YouTube and you want to share, please do. We've got a difficult or easy one for you, depending. We'll find out. Do you have a favorite spot to dive in the world?
Ooh. Yes, but in different. Well, I have several, but some in different ways. So the Red Sea and diving there is or was amazing. There's some now that are not that good. The reefs, because it's just so colorful and so beautiful. I did go diving in the Galapagos, and there you don't have the coral reefs like we do in the tropical areas that are so colorful, but the other creatures around you, like we had to be careful that we don't put anything down because creatures would just go and take them. And so it was a different diving experience.
So funny. Tom Thompson, we're going to come back to you guys, 5 6s. Unmute your mic and take us away. Hey.
I have a student approaching now. I wasn't sure they were coming back.
Oh,
Here
we're coming
she
back.
is. Oh, excellent.
We'll do another round too.
She is.
Hi. Is it true that if you pluck a piece of coral out of the coral reef, all the corals will stop having any color?
Ooh.
So if you take a piece of coral, and I think you're referring to a hard coral usually, then the animal cannot survive outside of seawater. And so the animal dies. And what you get left is the skeleton. And because the skeleton is white, if you've ever seen bones like of a chicken or whatever after you eat it and you let them dry, they become white. So what you have left is a rock that is white, because the coral animal is dead. With octocorals, they also die. They can't live outside of seawater, but depending on the color of their skeleton, they may appear a little brownish or something, but that's because of pigments, not because that the animal or the algae are alive.
Great question. And just to be very clear, the rest of the coral reef won't lose their algae just because one coral is taken out. So if you have a whole coral reef and you take one coral away, the rest aren't affected by that. But if you have something like warming, then all of them might be affected together, just in case that's where your question was headed. But I love it. Fantastic. We are going to come back to you guys for another one in a minute too. But Ms. Steinhoff, come on in and take us away. Hey.
Is there clownfish in the Caribbean?
Excellent question. And the answer is no. Clownfish occur in the Indo-Pacific. So you could see clownfish. The Indo-Pacific includes areas like Australia, Fiji, the Red Sea, the Gulf of Aqaba and Eilat, all those places, but not in the Caribbean.
Rats! We have to go a little bit further to go dive on some coral reef with clownfish on them. I love the question, though, guys. Thank you so much. YouTubers, feel free to chime in as well. We're going to head back to Tom Thompson for one more, Miss Steinhoff, and then we'll wrap up from there. Hey, guys.
Hi. What is the most common species of fish?
No pressure at all, Tammy. I love it.
Well, as with the anemone fish question, it depends what sea you're in because there are different fish species. I would say I can't really answer that because it depends on what the reef is and what the conditions are on the reef. So that would be a difficult one to answer. We've
stumped the expert. This is the joy of exploring by the seat of your pants. Is there's always one question that's unanswerable, and this is true. If you watch footage of different reefs around this planet, there will always be a different most common fish. And we will probably never know that. There's simply too much ocean to actually assess. Oh, there's 5 billion of this one and 10 billion of this one. But we'd be talking billions, if not trillions, of individual fish for the most common species, which is really cool. So great question, guys. All right. Time flies and you're having fun. We are nearing the end of the broadcast. I do want to note, I'm going to pass this along in the chat, but if you want to read Dr. Tammy's article, it's fantastic. Frontiers for Young Minds does such amazing stuff. We've still got a few more programs in our Ambassadors of Conservation series in collaboration with If Then. So please do check those out. We'll share all those resources. Lots of extra opportunity to learn. But with one final question, Ms. Steinhoff's class, come on in and take us away.
Are there Florida Keys a healthy reef system?
Ooh, good question.
Excellent question. The quick answer is no. There are a lot of challenges with the Florida Keys, but there are a lot of efforts to protect them. So in the past, when people built houses in the Florida Keys, when you go to the bathroom and you flush the toilet, it needs to go somewhere. And in the past, that somewhere was literally going on into the water. And now we know better, right? And so that doesn't happen anymore, because if you do that, you're going to have a lot of nutrients in the water. So that doesn't happen anymore. And there's a lot of restoration efforts. There's a lot of effort to grow corals and to put them back on the reef because the reefs have suffered from, there have been a lot of ocean warming. So there's a lot of increase in temperature and corals dying, but there's a lot of effort to save them and to keep them going. So it's a not great, but humans are aware of that. And we're helping that process to conserve them.
It's the perfect message because around this planet, there are a lot of ecosystems under a lot of threat because of our actions. But there's so many people like you that are working to understand that, fix that. We feature stories like this all the time at Exploring by the Seat of Your Pants. And truly, like the entire Ambassador series is all about that. So if you want to check out some really positive, hopeful stories, there's lots out there. And I love when we get questions like that. So thank you so much, Ms. Steinhoff's class. And before we wrap up and bring in our kids to say a big thank you and farewell, is there any final message you want to leave us with today about coral reefs?
Well, coral reefs are amazing and very, very important to our planet. Even though you may not live by a coral reef, you are touched by it in one way or another. So like with any of our ecosystems, it's important to conserve coral reefs. And on the tangential part of that, as a marine biologist, I pursued what I found interesting, and I hope that you pursue careers that you enjoy doing.
No better message than that. And again, I hope you get the chance to go diving in your life. It really does change your whole perspective on this planet. It's a really, really special thing to do. Classes, thank you so much for your enthusiasm, your interest, your great questions today. If you're on YouTube and you want to scream and yell too, you have our permission to annoy the principal. But Ms. Steinhoff's class, our Tom Thompson crew, thank you so much for joining us live today, and have a wonderful rest of your day.
Bye.